Hello friends, this is Rashmi Singh. Welcome to my channel Unraveling Science. Let's have a moment of science please. He who asks a question is a fool for 5 minutes. He who doesn't ask question remains a fool forever. Today's topic is acid, base and salts. Class 10 chapter 2. In this video, we are going to learn about acids, its property and types, bases, reaction between acid and base, strength of acid and base, pH scale, salts, types of salts, chemicals from common salt. Acids. The term acid has been derived from the Latin word acidus, which means sour. The substance which gives H+ ions in an aqueous solution are known as acids. For example, sulfuric acid gives H+ ions in sulfate ions. Examples of acids are hydrochloric acid, nitric acid and sulfuric acid. Properties of acids. Physical properties, they are sour in taste, change the color of blue litmus to red, acid solution conduct electricity, gives H+ ions in aqueous solution. Chemical properties of acids. Reaction with metals. Acid react with metals to liberate hydrogen. As you can see, zinc reacts with sulfuric acid to give zinc sulfate and hydrogen gas. Reaction with metal carbonates and hydrogen carbonates. Acid reacts with metal carbonates and metal hydrogen carbonates to liberate carbon dioxide. So calcium carbonates react with hydrochloric acid to give calcium chloride, water and carbon dioxide. And sodium bicarbonate reacts with hydrochloric acid to give sodium chloride, carbon dioxide and water. Reaction with metal oxides to form salt and water. Calcium oxide reacts with hydrochloric acid to give calcium chloride and water. Natural sources of acids are: from vinegar we get acetic acid, from apple malic acid, milk gives lactic acid, and formic acid, grapes tartaric acid, tomato oxalic acid, and lemon citric acid. Types of acids. On the basis of their source and occurrence, acids are of two types: mineral acid and organic acid. Mineral acids. Acids that are obtained from rocks and minerals are known as mineral acids. Example is hydrochloric and nitric acid. Organic acids. Acids that are present in animals or plants are called organic acid. Example lactic acid, formic acid. Strong acids. The acids ionize more or less completely when dissolved in water. Examples are hydrochloric acid, nitric acid, hydroiodide acid, precolic acid, cholic acid. Weak acids are the acids which ionize to a small extent when dissolved in water, like sulfurous acid, methanoic acid, phosphoric acid, nitrous acid, etc. Bases. Substances that give hydroxyl ions in aqueous solution are called base. For example, sodium hydroxide and potassium hydroxide. Physical properties of bases are: bitter in taste, turns red litmus blue, gives hydroxyl ions in aqueous solution, does not conduct electricity in aqueous solution. Chemical properties of bases. Reaction with metals. Strong acids react with active metals to produce hydrogen gas. For example, zinc reacts with sodium hydroxide to give sodium zincate and hydrogen. Reaction with non-metallic oxides. Bases react with non-metallic oxides like acidic oxide to produce salt in water. For example, calcium hydroxide react with carbon dioxide to give calcium carbonate and water. Sources of base. Its sources are blood, household bleach, hair removal cream, drain cleaner, oven cleaner, household ammonia, egg white, etc. Reaction between acids and bases. Acid reacts with base to produce salt and water. This reaction is known as neutralization reaction. As you can see in the picture, when hydrochloric acid reacts with sodium hydroxide, that is base, it gives salt and water, salt NaCl. Acid or base in water solution. We know that acid produces H plus ions in the presence of water. H plus ions cannot exist alone, they exist as hydronium ions. As you can see here, H plus ions react with water to give hydronium ions, and when HCl reacts with water, it gives hydronium ion and chlorine ions. Bases when dissolved in water gives hydroxyl ions. Bases soluble in water are known as alkali. Like sodium hydroxide in presence of water gives sodium and hydroxyl ions. Similarly, magnesium hydroxide gives magnesium and hydroxyl ions. While diluting acid, it is recommended that it should be added to water and not water to acid, because the process of dissolving an acid or a base in water is highly exothermic. So as you can see in the picture, we should add water to acid. If water is added to acid, the heat generated may cause the mixture to splash out and cause burn, and the glass container may also break due to excessive local heat. Mixing an acid or a base with water results in decrease in the concentration of hydronium ions and hydroxyl ions per unit volume. Such process is known as dilution. Indicators. Indicators are the substance that change their color or odor when added to an acid or an alkaline solution. So you can see the indicators. Example are litmus paper, phenolphthalein, methyl orange, etc. Strength of an acid or a base. Strength of an acid or a base depends on the number of hydroxyl ion produced by them respectively. Larger the number of hydrogen ions produced by an acid, stronger is the acid. Similarly, larger the number of hydroxyl ions, stronger is the base. pH scale is the scale that is used in measuring the strength of an acid or a base in a solution. P stands for potens, which is a German word that means power. So here you can see the acidic, alkaline and neutral solution. If pH is 7, it means the solution is neutral. If it is greater than 7, it means the solution is alkaline, and if it is less than 7, it means solution is acidic. So here you can see if we move below 7, so as we move below 7, the acidic nature increases, and if we move above 7, the basic nature of the solution increases. Importance of pH in everyday life. Our body works within the pH of 7 to 7.8. When the pH of rainwater is less than 5.6, it is called acid rain. Plant soil requires specific pH range for the healthy growth. The stomach has a pH of about 2 due to the presence of hydrochloric acid in it. It is needed for the activation of pepsin protein required for protein digestion. When we eat food containing sugar, then the bacteria present in our mouth break down these sugar to form acids. The acid lower the pH in the mouth. Tooth decay starts when the pH of the acid formed in the mouth falls below 5.5. Then the acid becomes strong enough to attack the enamel of our teeth and corrode it. This sets in tooth decay. The best way to prevent the tooth decay is to clean the mouth thoroughly after eating food. Many plants and animals protect themselves from enemies by injecting painful and irritating acids and bases into their skin. For example, like honeybee stings a person, it injects a liquid into the skin. Rubbing with mild base like baking soda solution in the stung area of the skin gives relief. Similarly, when a wasp stings, it injects an alkaline liquid into the skin. Rubbing it with mild acid like vinegar on the stung area gives relief. Salts. Salt is a compound that is formed by the reaction of acid with base in which hydrogen of the acid is replaced by a metal, and this type of reaction is known as neutralization reaction. So you can see the bases and reacts with acid to give salt and water. Classification of salt on the basis of pH values. First is neutral salt. Salt solution of strong acid and strong base are neutral in nature with a pH which is equal to 7, and they do not change color of litmus paper. Strong acid plus strong base gives neutral salt. pH is equals to 7. Examples are sodium chloride, sodium nitrate, sodium sulfate, etc. Acidic salt. Salt solution of strong acid and weak base are acidic in nature with a pH value less than 7. They change the color of blue litmus solution to red. Strong acid plus weak base gives you acidic salt with a pH less than 7. Example is ammonium sulfate, ammonium chloride. Basic salts. Salt solution of weak acid and strong base give basic salt with the pH value more than 7. They change the color of red litmus solution to blue. So weak acid plus strong base gives you basic salt, pH value more than 7. Example is potassium phosphate, sodium carbonate, etc. Chemicals from common salt are sodium hydroxide, bleaching powder, baking soda, washing soda, and plaster of Paris. First is sodium hydroxide. When electricity is passed through an aqueous solution of sodium chloride, it decomposes to form sodium hydroxide, as you can see in the reaction. Sodium chloride reacts with water to give sodium hydroxide, chlorine and hydrogen. At anode, chlorine gas is collected. At cathode, hydrogen gas is collected. And near the cathode, NaOH solution is formed. Uses. Hydrogen gas is used in fuels and margarines. Chlorine gas is used in water treatment, PVC and CFCs. HCl is used in cleaning steel and medicines. Sodium hydroxide is used in degreasing metal, soap and paper making. Bleaching powder. It is produced by the action of chlorine on dry slaked lime. So you can see chlorine when reacts with calcium hydroxides give bleaching powder and water. Uses are bleaching cotton and linen in the textile industry, bleaching wood pulp in paper factories, as oxidizing agent in chemical industries, disinfecting drinking water. Baking soda, also known as sodium hydrogen carbonate. So sodium chloride reacts with water and carbon dioxide and ammonia to give ammonium chloride and baking soda, that is sodium bicarbonate. It is mild non-corrosive base. When it is heated during cooking, sodium bicarbonate gave sodium carbonate, water and carbon dioxide. Uses are for making baking powder mixture of baking soda and tartaric acid. When baking powder is heated or mixed with water, carbon dioxide is produced, which causes bread or cake to rise, making them soft and spongy. As an ingredient in antacids, and it is used in soda acids and fire extinguishers. Washing soda. Recrystallization of sodium carbonate gives washing soda. It is a basic salt. As you can see here, sodium carbonates reacts with water to give washing soda. Uses are in glass, soap and paper industry, manufacture of borax, cleaning agent for domestic purposes. for removing permanent hardness of water. Plaster of Paris, also known as calcium sulfate hemihydride hydrates. On heating gypsum at 373 Kelvin, it loses water molecule and becomes plaster of Paris. It is a white powder, and on mixing it with water, it changes into gypsum, as you can see here. Uses: doctor use plaster of Paris for supporting fractured bones. It is used for making toy material for decoration. It is used for making surface smooth. Water of crystallization. It is a fixed number of water molecules that are present in one formula unit of salt. Example is like copper sulfate. Here has 5 water molecules. Sodium carbonate here has 10 water molecules, and calcium sulfate has 2 water molecules. Thanks for watching. Please do like, share and subscribe.